Kevin Ogles, who's in the back, who works with me over at the Tech Center, he's taking the classes this week. Back in January of 2010, we went to a meeting up in Virginia, and the NRCS folks up there had one of these, and they showed us, we were down in Fredericksburg, and he showed it to us, and we said, you know, we've got to get one of these and use it at the Tech Center and use it around in different places. So by the end of the year, we had one, and since that time we bought another, and both of us taken it all over the eastern part of the United States. And since that time, already some western states had them, but a few others have bought them, a few midwestern states, but about half of the eastern states now have purchased them. I know Vermont, Connecticut, Pennsylvania, New Jersey, South Carolina just now purchased 3. Georgia and Tennessee have purchased 4 each. So it's a great demonstration. I don't know if they all realize how hard, how much work it is to put one of these things on, but they'll learn. But it does a great demonstration. So that's where kind of the background on that. So what we do is try to show different treatments, and I promise you guys, you know, the water's going to go to about right here. So, you know, we could say that as a dance floor, but you won't get wet if you know, don't get any closer than that. FYI. So here are the treatments we're talking about. Here's treatment, and I know you guys probably, most of you deal with cropland. Come on up a little bit. I know most of you people deal with cropland, but I do. You know, we got 5 treatments I can use. I did this demonstration the day before yesterday in Lexington. So four of the treatments that I have are 4 treatments. I didn't mean to get this close. No. But 4 of the treatments that we have I used before, so they're already wet from using them. And so I'm reusing those, and this one down here is a new one. So we have a well-managed pasture. Well-managed pasture, which you would gather, and we picked this up in Greensboro. And this is, of course, is not a well-managed pasture. And you don't have to be a rocket scientist or, you know, an agronomist or anything to figure out that that's down. And I'm going to admit something to you. My father still has cattle, and this came off our farm. And so I told him I needed some soil, or he might have thought it was going to be some good stuff I was going to talk about it. But it's an overgrazed pasture. You know, you have that. It's a pasture right near the barn, so it's where I always keep some cows, and they keep it grazed pretty hard.
Daddy, I need a goof plot. Oh, good.
Yeah, that's it. So that represents it is an overgrazed pasture. And also, and then over here, we've got your cropland. And what we have here is a no-till. It's been a continuous no-till farm for, 30 years at least. But in the last, and then they've done some, off and on done some cover crops, but in the last 5 or 6 years, they've increased their diversity in their rotation, and they've increased the diversity in their cover crops. And what we've learned, but there's basically 4 principles that we talk about with soil health, and they're pretty common, and there's science behind all those principles. One is disturbing less. So we've got very little disturbance because it's a long-term no-till system. Very little disturbance here. High disturbance because of the compaction issue and the overgrazing, so it's a biological disturbance. The other would be keeping living roots 12 months out of the year. 12 months out of the year. Why? And Sam may have said this, but you've got this biological activity going along on that roots, more biological activity going along your roots than anywhere else in your soils, right in that little 1/8 of an inch. That's where the bacteria feed, and that's where the protozoa feed on the bacteria, and so on as part of that soil food web. So that's where you have that going on. So if you've got several months where you don't have anything growing, it's basically a dead zone for that biology. So you want to keep that something growing so you can keep the biology living and cycling things. And so it's important to keep doing that. And one thing we have here in North Carolina in the southeast, we're so blessed with the weather to be able to grow things, you know, practically year round. So we can do that, and so that's something we have that other places don't have. The downside is because we're in the southeast, we have what? Real hot, humid weather. So when you have disturbances like tillage, it doesn't take a lot of tillage to eat up all that, you know, that carbon and the residue that we have put down through cover crops. So it's a trade-off because we need carbon in the soil and on the soil to feed those microorganisms, both in the roots and both in the residue. And that's the third principle, keeping it covered keeping residue on the soil. And why is that? Because that's the next place where most of that biological activity is going on is along that interface between the soil and the top of the surface. So you've got a lot of your microorganisms living there. The good mycorrhizal fungi, that's where most of that happens. What they do, I don't have time to go into all of it now, but they bring nutrients back into plants, and there's association they have with most plants. So keeping that residue. So that's the third thing. And then the fourth thing, as I was getting back to, is diversity. Because if you've got a lot of diversity, you guys know we always had that field where we grew tobacco every year because it was, that best field. But what happens after a few years? You got black shank, mosaic, and you start having problems. It's the same thing. You need diversity so you can have a diversity of microorganisms. The more different kinds of things, the better. That way, when you still have some bad things in your soil, you have this competition, and those bad things in there are outcompeted by the good things. Just like in your gut, you've got bacteria living in your gut right now. So a big variety of bacteria in your system keeps your system healthy because they're the bad things that get in there and the bad things that live there all the time. Big variety of stuff helps offset and outcompete the bad things. So it's the same thing. So that's your diversity. And then over here, obviously, this is your heavily tilled system. And I apologize because most of you guys, I'm sure, are from down east, and I didn't have time to go get coastal plain soils. So you've got to deal with what the Piedmont soils, and that if you've ever been in the Piedmont, you recognize this as a Piedmont soil. So, but the interesting thing is, we always try to get the same soil type, but we don't always do it. And I can't remember if it's exactly the same soil type, but it's the same thing. Believe it or not, these are close to the same soil types. Here is this. So what's causing the difference?
Organic matter.
It's building the organic matter, and you build the organic matter by getting lots of carbon back in the system. You do that through the residues, and then again, your microorganisms break that down. They build the glues. When they start breaking that down, they build up they have these glues, and they start building aggregation. And when you start building aggregation, you have pore space, right? Y'all with me? It's not even cold anymore. You build the pore space. And when you build that pore space up, you have places for water to go. It's held tight. It's held tighter in those pores. The water is held tighter. About for every pound of organic matter, it's about 2.5 gallons of water that's held there. So you've got that, and so the glues keep all that together as well. And then you've got the cover on top. And what does that do? That moderates the temperature. Think about that. You've got the moderating temperature. So when it gets really hot in the summer, if you're ever a kid and walking barefoot out in a plowed field, at the end of the day, it can be pretty hot. Well, think about your plants, how hot that is on your plants. The same thing. So you've got the moderating soil temperatures, keeping moisture at that level. You've got the water holding capacity with the soil, and then when it's had all it can handle, it lets the rest of it through. And of course, you've got higher cation exchange capacity, and your nutrients, as they're going through, the nutrients held tighter bonds and held into those organic matters. So again, this was vegetables, lots of tillage, lots of disturbance, low diversity, high diversity, less disturbance, less human input. And same thing factor over here. I did want to say about the grazing. We've got grass growing 24 years, so we got continuous root system, but I call it an enhanced root system because you're enhancing this root system by letting the above ground grow, more photosynthesis, so you've got better root system. Now my fifth one, we always end up with one that, what I'm going to do for this extra. I've got one left. And so the last 2 or 3 times I had this one on where I just took a conventional, like that's over here, and I put some residue on it because we have our conservation standards and NRCS. What is the minimum to meet our 329 standard? What we call the no-till, Rufus? How much residue do you have to have?
60%.
Yeah, well, it changed it. Well, we got really lax at one time. It became 30%, didn't it? Yeah, and then it's back. So this is probably 75, Rufus, 80%. So it's a lot of residue on it. So I'm always curious to see what happens when you put a lot of residue. That's one of our principles, but not all of them. It's just really following one of the principles, but you put it on the depleted soil system. So, I've talked enough. Yes,
But in the middle one, you don't have roots. You don't have a root system.
that's
This
right.
is-
It's just the cover.
Okay.
It's just the cover. So that's it.
There's one thing I didn't understand the first time I saw this.
Yeah.
But you got two jars per, one is catching the water that's going off the top.
Yeah.
And the other jar is catching the water that's infiltrating through the
Yeah, and we were going to talk about that at the end, but you stole my thunder. Thanks, Sam. That's it. No, he's right. He's right. You know, people say, well, I saw these rainfalls. I saw something like this 30 years ago. But most of our, you know, what we talked about 30 years ago was all about erosion. You know, it was all about what ran off. It was all about the sediment, which is important. Sediment runoff. So we weren't thinking about, you know, we were just thinking about keeping that from eroding. We weren't thinking about what's going through. And as we've been taught the first time I heard some of our folks talk, you know, we don't have a runoff problem, we have an infiltration problem because the water is not going through and not being used. And so that's what we want to see, the differences between the two. All right, Kevin. Kevin is my lovely assistant, and he's going to turn this on. Not now, but in a few minutes. In a few minutes, thank you. Yeah, it's going to get it'll get a little messy, but it is a farmer's market, so farmers are used to that.
First time I saw this back when I didn't catch what the two jars were, believe it or
I
not.
usually keep this one covered with that other board so we can show that at the end. So it takes just a few minutes to kind of get things going. And I know the first thing that some people say, and I always get really wet because I always get too close, and then I realize at the end that I'm cold. But one thing people say is, you know what, Steve, that's a heck of a rainstorm. And it is. And I know it's been measured before how big that storm is. But this is not a research demonstration. It's just a educational demonstration. The main point to make here is in the summertime in North Carolina, when it rains, it usually does what?
Of course.
It rains when it pours. It comes down pretty hard. And so, you know, so this does kind of give you an idea of what's happening. And growing up on a farm, you know, I used to think, wow, we got a rain. We got a hard rain. That's great. And look, hey, guess what? The pond's full. The pond's full. So now we can irrigate out of the pond.
Wow.
So when reality, we'd probably be a little bit better off if the pond wasn't full, because the soil, the water went in, it infiltrated, and was used by the plant. So keep in mind, and people talk about, you know, how much science do you have of this and that, but the science, the principles, the basic principles of this, again, I guess is one of the take-home things. There's lots of science behind it. There's lots of science behind less disturbance, you know, because again, once you till that soil, you open that up to oxygen, right? And so you've got those certain kind of bacteria that are in the soil that are kept in check. And so once you open that up to the oxygen, they start feeding on it. They start feeding on all the carbon that you have, those particular microbes. And they go crazy, and they feed on everything. And when you keep tilling, they run out of that available carbon that's easy to get to, and they start working on the glue. You remember I mentioned the glue before? They start working on their own, it's called kind of eating your own house down. There's nothing left, so they start eating their own house down. And once they do that, then you've got no pore space. They've eaten, think of the 2x4s in your house, think of termites. They've eaten that, so you get the water, it collapses on itself, it has nowhere for water to go. Oh, and by the way, if you're preparing some land for some crop, when you're doing that tilling, when you have that respiration and you have them eating that carbon, what else is happening? What else is happening? They are also, at that same point, they're giving off they're making nitrogen available, right? They're moving stuff to nitrate. And here you don't even have a plant in the ground, and you're moving stuff to nitrate. What's going to happen to it? It's going to leach out. There's no plant to take it up. If a plant's there, it can take some of it up. No plant there, it just goes and you leach it out. So that's another reason to have that, where you keep adding the carbon. Keep in mind, carbon, it's all about providing food and habitat for the underneath, what we call the underneath critters, the underneath herd, whatever you call it. Because you've got to have that for the bacteria, you've got to have that for mycorrhizal fungi, you've got to have that, and it builds on itself.
You ever stuck a rain gauge in each one of those?
Everybody asks that, yes. And it does, you know, if you're, and a lot of you guys, some of you guys are NC State, and I was with Jim Dunphy. I showed this day before yesterday, and I said, Jim, he's the soybean guy. I said, don't say anything about how much it's doing. I don't know right now, but you know, but you're right. They always want to know how much it is. That's good, Kevin.
We get some pretty intensive rainfall events, but that ain't far off.
Well, the interesting thing too is in this flat land, you think, wow, it's not an issue. You're gonna start. You know, the interesting thing too, you think on this flat land or semi-flat, we don't have an issue. But I've seen it too where the water just doesn't go in, even if it's 1% slope. It's going off, and guess what? If you got chicken litter you just put out there, it's going off as well. So let's look first. I didn't let them fill all the way up. Let's look at the grazing systems. And you know, when I first started doing this, was the biggest surprise to me of any, because I thought, wow, if we've got grass growing out there,
That's wild.
that's okay. That's all you need to worry about. And as a district conservationist in a couple of counties, I prided myself, I'm going to go fence out that creek, and I'm going to put some water tanks on there. And they said, what about the pasture? Our pasture's all right. You know, it's all right. I don't care. I don't care. But you think about it now, when you've got manure and urine and whatever else you put out there on that pasture, and all you got is this little bitty buffer down here in the stream. Think about when you start getting those rains, what's going on. The water's not going in. It's just as big a problem for livestock folks. They don't know it because you don't think about it. You don't think about what's going on, but it's just as big a deal on grazing land as it is cropland. So if you're wanting to maximize your potential on grazing land without having to feed hay 8-9 months out of the year, you know, think about growing these grasses up. You get more photosynthesis, letting the roots go down. You get more biological activity. And by the way, if you had more residue here along with this grass and a big old 1,400-pound bull or whatever stomps on this, it doesn't cause as big a deal as it does right here, because here you have this compaction. You've got rid of your pore spaces, you don't have any residue, you start having compaction, and you start having runoff. And that was really as big a surprise to me. It's one of the things I've been doing, worked for this agency as long as I had, and I really didn't understand. So, well, look at the we had one of the principles. We had residue, we had cover. So we talked about that in NRCS for years, having some cover. But if the soil is not functioning, you know, we still don't have functioning soils, you still got some of the same problems you had before. You've got runoff, and the soils are not functioning. You don't have the pore space, you don't have the biology, and it runs off. And obviously, the no-till system, so this guy, he gets that hard rain in the summer, the water's going in and being used by the plant through the profile. It's not running off, so he's making the most out of whatever that hard storm rain he gets. And you know, and it's because, again, that you fed the biology with residues and the roots and the roots that are sloughing off. You fed that biology, and it's able to build that aggregation, build all the kinds of pore spaces. Earthworms, 10, 20, in a couple of shovelfuls. Those earthworms get in there, and believe it or not, I've seen coastal plains where you didn't have earthworms, and they start building up the biology and started getting a little more organic matter. It takes a little bit longer in coastal plains, it does, but I've seen it in 6-7 years increase the organic matter by 1%. Organic matter is huge. What is that? That's about, I think, my memory's right, 13 to 4% organic matter will give you 14,000 gallons per acre of water holding capacity. Think about times, yeah, maybe if you're dry for several months, you're going to have to irrigate, but if you just got short-term droughts, you wouldn't have to worry about that. So it's got that going on here. All right, what about this vegetable guy or girl? Or they had here. Think about that. Nothing went down into the profile, and it all ran off. And so again, it collapsed on itself because you didn't have the residue, you didn't feed the biology. There was very little biology, so you start getting this collapse. So the other thing we like to do, any questions so far? Does it all make sense? So far, so good. So the other thing we like to do, and there's my lovely assistant, Kevin Ogles again. He'll be taking autographs later. So, is we like to take, how many of you have seen this before? I know Rufus back there has, so a few of you. I've done it. I've done it. I figured out this is my 13th time this year. Kevin's done it a few times, and then we've had some other people in the office done it too. I told people the other day, I said, I counted up on my fingers, this is the millionth time I've done this. So it seems like it sometimes. But, so what we do is like to look at what's going on underneath, and I like to take the conventional soil and look at what's happening. So this, you can see this is about, it's about 3 inches. That's as good as we can do. It's about 3 inches deep. Is all that is, and the other thing is you know, it works on your back. I gotta get up. Don't want to drop it. So let's look. That floor is slick, so be careful, guys, if you get up close. Yeah. So it's about 3 inches thick. So you think when you get that hard rain, and you know, I talked about the first, you know, along the roots, all the activity by the bacteria. It's like, you know, the animals on the Serengeti Plain feeding on one thing, feeding on another. It's a trough. Hogs at the trough, but the next is that first 3 or 4 inches of soil. So what's going on there? So you can see, really, what I've looked at this before. It's about 3 inches, maybe about 1/8 of the inch. About 1/8 of an inch went through that hard rain, and it happens in coastal plains as well. You saw Ray's thing the other day. One of the first times we went to Kinston and did some soil health course for our folks, and I took a ring, 6-inch diameter ring. They're 6 inches in depth, and I put it in the ground. Well, in the ground, easy. You don't need a hammer on that soil in Kinston on the research farm to get in the ground. You just push it down. Push down 3 inches, so 3 inches above, 3 inches below, and then I poured. How many millimeters of water? Is it 400 millimeters of water you put in it? And I said, this is beautiful soil. Let's put water. What did the water do?
Bubbled up.
It sat there. It sat there. It didn't even go in on this, because everybody says, I've got to till it up because I got to fluff it up. I got to get it warm. I got to get it where water will go in. And so our whole thought process, and mine too, had completely been in the opposite. And it's the same thing with folks now driving down the road, down through here. I don't want to say the wrong thing, say the wrong people, but you know, there's a turbo till right beside the road, and they think, wow, you know, I'll just use a turbo till. You know, it's not so bad. But you know, it's still that you're still allowing that oxygen to get in that soil. You're still allowing that certain bacteria to break that down too rapidly, and that some studies have shown right at that 3 inch layer, you start getting compaction, because that's how deep they usually go, and you start getting about half the infiltration. So it's a lot of the same thing. So my whole shift in thinking, you know, has come a long way, because I'm pretty slow-minded, and that takes that. So, any questions so far? I have a couple more things. Anything? Does it all make? Is it crystal clear, Rufus? No. Let's look at the plants over here. So let's turn this way real quick.